Kia ora koutou. This video is for my 13 MCA class for July the 22nd, but it's also good if you're doing some A-level revision or if you're looking for quite a tough level 3 differentiation question. So this has got a bunch of trig in it and some calculus and some concepts from way back in level 2. So let's start by reading it. It's quite a tricky one to see what to do until you get into it. But we've got a curve with this equation, and a is a positive constant, and we're told that this curve has got only one point in the interval from 0 to half of pi where the tangent is parallel to the x-axis. So find the value of a and state the exact value of the x-coordinate of this point. So obviously the first thing to think about is that the tangent gradient comes out of the first derivative, so we're going to differentiate and we're going to use the product rule for that. Then we're going to set that derivative equal to 0. Right, because if the tangent is parallel to the x-axis, it must have a gradient of 0. I've gone over to GeoGebra to show you what's going on here, because what we've got is a family of curves, and they're all a bit different, and we're trying to find the one curve where there's one point where the tangent's parallel to the x-axis. So I'll see if this works. Let's go to GeoGebra and see what we've got. Okay, so I've set this up with a family of curves. I can't write on this. I'm going to put the slider on now, and you're going to see the value of a is going to change. What we're interested in is look at the screen between 0 and pi on 2 and see if there's a point where the tangent is parallel to the x-axis. So at the moment the value of a is starting off at negative 2.8, and you can see that there's nowhere on the screen where the tangent is parallel to the x-axis. So now I'm going to change it. And look, these curves are changing, right? So I've stopped it here, and you can see that there looks like there's a whole region where the tangent is pretty close to being 0. Right? I'm going to keep it moving again now. Okay, and so you can see some pretty crazy things are happening to this curve. The value of a is changing, and the curve's changing. So you can't do this in the exam, but if you can visualize this as being what the problem's about, it might help you a bit. So I'm going to stop it here. You can see again, we've got no value that's going to give me a tangent parallel to the x-axis. So now let's go back and just work through the problem with some algebra and calculus and see what we can figure out. Okay, so we'll start by differentiating. We might write down what we're going to do. So dy by dx is equal to 0 for the tangent to be parallel to the x-axis. So differentiating this, I get dy by dx is equal to negative a times e to the negative ax. Right, so that's the first function differentiated. So that's u dash v plus now v dash u, so sec squared x times e to the negative ax, and I need to set that equal to 0. So we're going to factorise that with e to the negative ax out the front, times sec squared x, working from this end, minus a tan x, and that has to equal to 0. So e to the negative ax doesn't equal 0, so the solution has to come from this factor. We've got sec squared x equals a tan x. Now I can play around with this, and I could write this as 1 over cos squared x is equal to a sine x over cos x. But it's not obvious how I'm going to solve that, right? Because I've got two things. I've got x and I've got a. So I need to go back to the question and look for another clue. So back in the question, this is telling me that there's only one point in the interval where the tangent is parallel to the x-axis. So I'm trying to solve this quite unpleasant trig equation, and I'm looking for one solution. So when we see a sec squared, we should think about the Pythagoras identity and think what would happen if I rewrote that to match up what we've got here. We've got tan over here, so sec squared is equal to 1 plus tan squared x, and that's equal to a tan x. Now I've got a quadratic, and what you should be starting to think is to have one solution. The discriminant of a quadratic has to equal 0. So we're going to try and turn this into a quadratic equal to 0. So tan squared of x minus a tan x plus 1 is equal to 0. We're trying to find the value of a. So for one solution, we need to have b squared minus 4ac is equal to 0. So b squared minus 4ac is equal to negative a squared minus 4 times 1 times 1, which equals 0, giving me a condition of a squared equals 4, and a is equal to 2 or negative 2. But we know that a is a positive constant, so a must equal 2. Right, let's go back to the question and see what we had to do. We're nearly there. So we found the value of a, and we're going to state the exact value of the x coordinate at this point. So I'm going to hop back to GeoGebra now, and we'll have a look before we do it algebraically. I'm going to set the value of a to 2. Not quite. A is 2.8. So you can see here that we're getting close to having, there's a of 1.9. That'll do. Okay. So a of 2 is very close to that. And you can see that we're going to have a tangent in here, one tangent that has got a gradient of 0 that's parallel to the x-axis. And we need to figure out where that is. Okay, so if I want the tangent to be equal to 0, I'm going to go back to my derivative here. So dy by dx equals 0 happened when this is true, but now we know the value of a is 2. So we're going to substitute in a equals 2, and we're going to solve the equation. Or even better, we'll do it from this version of it here. And you can see that we're going to get a perfect square. So tan squared x minus 2 tan x plus 1 is equal to 0, which gives me tan x minus 1, all squared, equals 0. So the value of x is going to be the one that has tan of x equal 1, and we know from basic trig or from our special triangles that the principal value of that will be when x is equal to pi on 4. Okay, so we know that from our special triangles as well. So I think that's all we have to do, right? So the x coordinate is what we're asked for. We're asked just for the x coordinate and not for the y coordinate or anything else. Okay, so there you go. I think that's quite a tricky question, just for the last bit to see what to do. I think the first part's really obvious, and I think you got about half the marks just for differentiating and setting it equal to 0. I'm going to try and do the other questions for class tomorrow over the next hour or two. Hopefully you haven't watched this before you've tried the questions.